everyone. Welcome to the Cohere for AI Computer Vision community. We are meeting today in that respect with a special guest speaker who I'll introduce in a couple of seconds. But first, for the new attendees today who haven't attended previous sessions, you just wanted to give a quick overview of Cohere for AI, and that'll be a great segue into our speaker in that respect. First of all, my name's Amit Taylor. I'm one of the co-leads for Cohere for AI's Computer Vision community, and I'm also joined by Benedict, who is also one of our co-leads. If you want to introduce yourself, Benedict.
Yeah, hello everyone. My name is Benedict. I'm the co-lead of the computer vision group at Cohere for AI with Amit. And nice meeting you and nice having you here with us. Thank you.
Okay, so with that being the case, especially again for those of you who are new to Cohere for AI, Cohere for AI, let me go ahead and start my slide deck here. Cohere for AI is a hybrid research lab and open research community that's dedicated to contributing fundamental research in machine learning, and it works to help solve some of the field's most challenging problems. And more importantly, what Cohere for AI does is it creates more points of entry into machine learning research. So those are sort of the overarching theme of Cohere for AI. We do this in a number of ways. Probably the most visible way is via guest speakers, of which we have a wonderful guest speaker today. And during the course of the typical month, we have a number of guest speakers in different disciplines. Today, of course, is computer vision, but we also focus on a number of other verticals or a number of other topics within Cohere for AI. And in addition to the guest speakers, we also have different initiatives for the community as well. One of the initiatives that we're right in the middle of right now is an initiative called Expedition Aya. And essentially that is a 6-week global challenge for multilingual AI researchers to connect, collaborate, and compete for some pretty cool prizes. So Expedition Aya is just ending, if I'm not mistaken, I believe either early this week or late last week, and that was one of our big initiatives. But probably the thing that Cohere for AI is probably more known for, at least in terms of its programs, is its research program. So Cohere has a Cohere for AI Scholars Program. And essentially what this Cohere for AI Scholars Program is it offers a full-time paid opportunity for diverse emerging talent to engage in cutting-edge machine learning research with world-class mentors within Cohere and outside of Cohere. And it runs from January to July 2025. So we've done this before, or Cohere has done this before, and this is the latest cohort. And it starts in January, and the applications are presently being taken for this particular program now. And what I've done is I've left a couple of links in the chat with more information about Cohere for AI as a whole, our upcoming topics, and the Cohere for AI Scholars Program. Finally, with no further ado, I want to go ahead and introduce our guest speaker for today. Today, I'm proud to introduce our guest speaker, Miao Zhang. Miao is a computer science PhD student at New York University, and she is also a graduate researcher at the Visualization and Data Analytics Research Center at NYU. Her research focuses on the intersection of computer vision and fairness and bias mitigation. And she applies, her research to real-world environmental and healthcare problems. So with that being the case, with no further ado, I'm going to go ahead and segue to Miao. Let me stop sharing, Miao, and you can go ahead and start sharing.
Yeah, thank you for a kind introduction, Amit.
You're welcome.
Present. Could you see my screen?
Yeah, we sure can.
Yeah, awesome. Yeah, hello everyone. I'm very excited to join this community today and to share our work. So I will hopefully give a very brief presentation over the idea of the work, and we will discuss afterwards. And also, please feel free to type or speak when I talk. And yeah, look forward to your opinions.
Okay.
So we shall start, I guess. The title of the project is Common Sense Bias Modeling. Frankly speaking, before working on this, I did not even know what is common sense. Like, seems a very big concept. So I searched on Wikipedia. It says it's the kind of knowledge or information that is, shared in human society, not necessarily spoken or written, but everyone knows about it. I remember an example that someone asked a large language model, do you know whether a child can places his left feet inside of the door and right feet outside of the door? And the model says no, because he never saw such cases. But the human can give the right answer. So I guess common sense is a level of intelligence beyond the machine, or what the machine is trying to approach. And that is one of the motivations, that is to leverage such information that model has not yet captured to help it for better learning. Yeah, that's like the brief context. And before diving into the idea, I would like to introduce the responsible AI context in bias modeling. There are multiple types of bias inside of a data set. It could be like one group being underrepresented, or one group samples being missing or disrupted. And in this work, we only focus on the spurious correlation problems, that two features often co-occur or never co-occur together. So the model naturally builds a connection between them, and that connection is not robust or generalizable to unseen or real-world data. I refer to this work, very recent work on ICML, because they study such problem on a large foundation models. They find that even though larger models have better groundings and may have used larger pre-training data to achieve better reliability and performance, they are still vulnerable to this fundamental learning problem. As we can see in this example picture, this is CLIP model trying to recognize pacifier. And when the baby shows up, the model's attention is on the baby's face. That's understandable because pacifier always appears with the baby. But if the authors replace the baby's background into a dog, the model has no idea where to look at. So we use the term spurious correlation for such problem. And even beyond that, image data set can include a wide range of features, including those not labeled, because label is limited. But how should we tackle with the trivial features and their connections in the data set, and to ensure that they do not affect model's performance? This is a cat example that MS COCO dataset, object detection dataset, we find that cats always co-occur with the suitcases. And suitcase is not in the 80 labels of the dataset. So technically, this features distribution is unknown. However, such connection may lead to a spurious visual cue for a model. Whenever the model recognizes a cat, whether a suitcase is there will affect the prediction. And similarly, cat also co-occurs with keyboard or laptop a lot. So this is a more comprehensive list of pairwise feature correlations that we analyze. On Celeb A dataset, it's a facial attribute recognition dataset. And we find that there are multiple correlations, such as earrings and heavy makeup, and the gender-related ones, such as men and no smell, So there are more images of women with a smile, but like more images of men with no smile. Also, there's a very strong connection between like a receding hairline and the gray hair. This is also understandable, but we would not want the model to recognize like a hairline situation based on the color of the hair. Yeah, a similar correlation analysis on Cohere dataset on objects. I also marked some examples like photograph and the bathroom and the bathtub, also like a frisbee and dog. So there are like a very long list of correlations there. Also, I do want to note here that there are some natural ones, such as ocean and the wave. We view them as benign because they're naturally connected and robust and basically generalizable to every situation. So scope of this work was a little summary of the observations previously. So we faced two challenges in bias modeling for image datasets. The first is that even though there exists a large number of trivial features, it is expensive to annotate each of them. And also we cannot anticipate the problem, and that because the problem also depends on the downstream task, what target we would like to recognize. And the second, we view the current state of the art unsupervised bias mitigation methods to lack interpretability, because most methods use in-processing methods, like they train the biased model itself and find the signals from the model's embedding space. So which information cannot be interpreted by human, like so there's no transparency, like what bias has been discovered and what has been tackled. So that's also an interesting direction to proceed. So facing these two challenges, we hope to provide dataset practitioners a full picture of dataset bias and the flexibility to avoid concerned spurious features or shortcut learning in the downstream task, depending on the domains. Yeah, then one solution comes to us is to utilize the language-based description. Text-based natural language is a common sense rich modality. So we aim to extract the high-level information from the language to help with the image training. Yeah, pause here for a little bit to see if anyone has comments or questions.
There are none in the chat yet, Mia. We don't have any quite yet.
Yeah, awesome.
Okay.
Yeah, so we can have a look at the method.
Oh, I'm sorry. We do have one.
Sure.
Sorry to interrupt. So there's one question in terms of whether scaling doesn't help in bias mitigation.
Sorry, let me check whether scaling. Can you?
Or hey, Anirudh, did you want to just go ahead and come off chat and I'm sorry, off mute and ask your question?
Sure. Yeah. Oh yes. For your question, yes, scaling does help in bias mitigation, but here I think our like big context is that we're not sure what bias will show up or what bias is concerned by the user. So the first step is to like build a whole picture of the dataset distribution or composition, like whether the dataset is balanced or not. And for the second question, is the spurious attribute always easier to learn than the target one? Not necessarily, but the spurious attribute will affect, I guess, because I think the model depends on the bias to learn. Like if we do not have any bias or connections in image, the model will learn nothing. But we only want those good ones, not the spurious or sensitive ones. So that the model's goal is to learn the target feature, but we do not. The model also needs to look at the context or the neighboring feature of the target to help it to grab the target one. And so we do not want the sensitive context features to affect the prediction, if that makes sense. Yeah. Yeah, the third, thank you, Michael. This is like a good point. Yes, like wave and waving the hand, they have very different semantic meaning, even though they look similar. So I guess this I will introduce later in the method part, but we will encode the features like wave or waving the hand using large language models. And depending on the quality of the model, hopefully the model will cluster more semantically similar features instead of what like the words level. Yeah. Thanks everyone. I'll continue here. So I'll introduce the method common sense bias discovery. So the input corpus is a set of images and the corresponding descriptions. I know this is a pretty restricted requirement because human annotated description is expensive. So in this work, we also explore to using captioning models to generate captions, which has obtained similarly good results. So with the descriptions, the first step is to split the long sentences into smaller units to be able to match subregions of the image. And we use Species library to extract the noun phrases of a sentence. Here we do not consider other parts of the sentence like preposition, which will represent like a relations between features that's like a higher level of correlation we leave for future work. And with those noun phrases, we encode them into the latent space representations, non-token representation. We use the universal sentence encoder from Google. We do experimented with different types of models, including those general purpose ones like BERT. But considering the time consumption, like the inference speed and accuracy, we finally go with this model. The latent dimension of each non-token representation is 512. Then we will perform clustering in the latent space to cluster similar features. Since the number of clusters is unknown, we use hierarchical clustering. The method assumes each single sample as a single cluster initially, and gradually from bottom to up merges closed clusters until some distance threshold is met. Here we use the threshold of maximum distance, that for two clusters, the maximum Euclidean distance between any 2 points. Like if the distance is beyond this threshold, then we do not merge two clusters. This threshold parameter is trainable, and we also perform sensitive analysis on it. Like it should be trained for a different data sets. So here we obtained a list of clusters including semantically similar phrases, and this can be easily linked back to the original sample or captions. So we can derive their distribution across the dataset as a one-hot indicator. TF. The capital N here is the size of dataset, and T will be 1 if the feature appears in a sentence, and it will be 0 otherwise. With the one-hot indicators, we use the phi correlation coefficients to compute the pairwise feature correlations phi. And the fourth step is optional, but we do think this is necessarily and valuable, which is to let a human or domain experts to check the bias list and select those harmless ones or sensitive ones. Because we do have to get a lot of naturally connected features that is okay, such as a mouth opening and smiling. They're basically describing same object, and they do not need to be like tackled with. So we do think a human in the loop is a good interface here. Yes, so a little summary, the outputs from the description-derived signals includes that for any target class to recognize a list of highly correlated image features, and also the robust and spurious correlated features examined by domain experts. With this, I think the next step is to try to mitigate the influence of the spurious correlated features. The bias mitigation is a very lightweight, and it can be applied with any data resampling strategies given the feature distribution we have obtained. So here we just use state-of-the-art work from CVPRs called bias mimicking. The idea of it is to make sure that the ratio of different features is the same for each target. So given this TY target feature distribution, TS sensitive feature distribution, those conditions will derive a weight W that we use for each sample of the dataset. With this resampling, statistically, the model can ensure the independence between the feature S and Y. So data is balanced with respect to them. For experiments, we used these two datasets, the Cellup A, the face datasets with 40 labeled attributes. But their human-generated caption only includes 5 attributes. And the MS COCO dataset, it's more used for object detection or multi-class classification, but we adapted to binary classification tasks because we want to investigate the feature-to-feature influence. Also, we experiment with the vision language model generated captions to try to adapt this method to any image dataset. We use the LavaNext model, an open source captioning model. For downstream tasks, there are 2 metrics being considered. The first is the average accuracy to evaluate the quality of the classifier. We split the samples into 4 groups, and one group can be with or without target and the sensitive label. And when we take the mean of the accuracy of the 4 groups. And the bias mitigation matrix is following the literature of the worst group accuracy, which is the worst performer of those 4 groups. Yeah, this is like upstream output of the analysis results of methods. We will generate TXT files like this. It includes like a feature 1 and feature 2. Even though only one word is shown here, like a feature is a cluster of similar phrases and only a random one is selected to present. And we also attach the correlation coefficients as the column. So ideally, the human in the loop module will look through the list and select anyone that he wants the model to be tackled with. Bias modeling is important, speaking of both discovery stage and the mitigation stage. So to prove that the bias we discovered is actually useful, we perform downstream classification tests and see if the vanilla model with no mitigation has shown such bias. And yes, we find that if the model recognizes a cat, for example, the model's accuracy is influenced by the couch or keyboard. And similarly, the recognition of an umbrella is influenced by the person's appearance. You can notice a big gap between the worst performance and the average performance. So we compare to the unsupervised bias mitigation baselines, as I listed here. I would like to say most of them uses model-based methods that they cluster samples in a model latent space and to try to upweight the clusters that has lower accuracy. But different to them, we try to solve the problem from the data's aspect. And for the model's training, only lightweight resampling strategy is applied. So yeah, so I attached the results here. So you can see the CSBD, our methods has obtained more effective bias mitigation results. In the meanwhile, the average accuracy is not sacrificed. So to, I guess, to deeply investigate the reason behind that, we perform another embedding space investigation. We draw the TSNE for samples of the last fully connected layer for the cat classifier. And we mark the samples with target feature cat and sensitive feature couch with different colors, as annotated here. The vanilla baseline model had some issues with the decision boundary because you can see that when the couch appears, the blue samples and the red samples has partially mixed around the decision boundary. So they're like bias aligning samples that cannot be accurately classified. And similarly for the samples without the sensitive feature, no couch, which is the yellow one and the green one, they also cannot be perfectly split by the model. And after the intervention, the samples can be like classified much more cleaner. We also investigated the different like embedding space-based method and how they perform, like why they do not achieve a perfect mitigation. I guess from the figures here, we can see that most of them use the idea of reducing the discrepancy between samples of a same class. Like they compare to the baseline, they reduce the distance between the green and red samples. That's like the same class of samples. But however, they cannot resolve the issues around the decision boundary, or they do not avoid the influence from the sensitive feature couch. Yes, this is a short experiment session. I did not put the ablations or other sensitive analysis here, but we do perform several stages of ablations over the methods. Yeah, I'll have a short conclusion. So I guess from this work, we have an idea that there's a great potential in leveraging information textual descriptions for the debiasing supervision. And the derived bias that is rooted in data can be mitigated by a simple reweighting strategy and can be more effective than other like blindly unsupervised methods. Also, a good thing is that it's interpretable to humans. So I think that's a important goal for responsible AI. There are several future next steps we would like to explore. First one is that we only deal with pairwise feature correlations here. But in reality, I guess recognition of a target can be influenced by multiple different features. And how should we balance them all at one time or do a trade-off between them? That's a much more complex question. Also, there can be higher degree of correlations, like 3 features correlated together, but not any 2 of them. That's also a very interesting question to ask. And the second, we would like to apply to other vision tasks, including the dense prediction task, like segmentation or detection, that requires pixel level information. And we're interested to see how the bias mitigation will help the dense prediction task. Yeah, I think that should conclude this work, and I'll see if there's any comments.
Yeah, I'll kick off with the first question, Mia. So I'm curious, can you explain in more general terms how your reweighting strategy avoided introducing new biases during mitigation?
Yes, here. Oh yes, that's a good point. I guess the concern is to we read the data, there could be like a skew, like other balanced feature.
Mm-hmm.
Yes, that is like unavoidable, and but we kind of do not include this question here because we assume there's only one spurious feature to tackle for one target. Yes. So we do not tackle with that's one of the, I think, the future work I list. Like we do not tackle with any like possible features to balance them with respect to one target. I also think that's a little bit impossible, that you can only do like a according to priority, like try to fix the data. Yeah, but that's a very good concern.
Okay, makes sense. So we have a number of other questions. Hey, Anirudh, if you wanted to ask your question directly, you can come off mute, or if not, we'll read it from the chat.
Yeah.
Okay. So Anirudh had a question in the chat. Did you find any differences in bias between CLIP and aligned vision language models?
Oh, yes. So we use like 2 ways to measure the quality of vision language model, like generated captions. The first is the standard metric like SPICE to evaluate the semantics of the generated caption, which has like pretty good results because the current large models has good performance. Also, we draw this correlation map between human generated captions and machine generated captions, and like qualitatively they obtained very similar results. So I guess for now we do not find very obvious or explicit bias from outside large language model. Like also, only in terms of generating captions, they can do their job to provide like what's happening in the image. That's what we're our observation. Yeah.
Oh, okay. Okay, we had another question in terms of from Ulugbeck.
Mhm.
And the question was, what data set size have you used in general? What data set size?
Yep. Cellbase is a bigger one. I think it has around 40,000 of images, and
Oh,
MS Coco maybe 10,000 around.
okay.
Cannot remember clearly. But I do view that if we want to apply the method to much bigger, like millions or billions size of data sets, like the clustering stage should have a memory issue. Like some strategies like to split into flat classes first, then do the hierarchical could be considered. But yeah, adapting to very big data sets is a challenge.
Okay.
Yeah.
So
Mhm.
our next question is from Roman. It's a little bit of a longer question. Hey, Roman, do you want to come off mute to ask your questions if you wanted to add any nuances to it?
Yeah, sure. No, thanks. Thanks, Miao. Great, great presentation. I'm actually a PhD student
Oh
myself,
yeah,
and
great.
I'm actually leaning towards bias, and so
Mhm.
I actually love your idea. This is more leaning towards grounding and alignment. So, so
Mhm.
common sense may not always be universal across different cultures, different
Mm.
parts of the world. How would you measure and adjust for bias, in terms of to account for cultural norms, values, and
Mhm.
social expectations? It's a hard question, but I just wanted to hear your take on it.
Yeah, yeah, I do think that that's hard, and so here we leave it open, like as an optional human examination stage. So that's why we insist to include this, because I think the human from the culture or the nation should pick out the bias that's like following their vision to tackle with. Like in a more diverse country, the ethnicity like could be like a very severe bias problem that people put high priority on. Um, I think that kind of culture difference or emphasis is cannot be predicted by model. So yeah, we include the human to filter out like problematic biases. That's, yeah, that's the current solution, I'd say.
Yeah, thank you so much. I'll let you reach out to you offline.
Yeah,
Would love to, talk more about that. Thank you so much.
yeah, sounds good.
Yeah, thanks for the question, Roman. So do we have any other questions from our attendees today? I know, Benedict, you haven't put in a question quite yet.
No, I haven't. That's because I don't have any. I don't have any.
Oh, okay,
Thank you.
all
Yeah.
righty.
I
So,
will say that the sampling approach to reweigh the samples for the purpose of mitigating bias it was actually very interesting to me. Very interesting, very simple, very intuitive, but also very interesting. So I'm just curious, how exactly did they just come up with that technique? If Miao could just answer.
Um, sorry, do you mind repeating it?
Sure.
In
So my question is, the approach you took to resample the data
mm,
samples, right? I looked at it and
mhm,
it is very simple, very elegant. So I'm
mm.
kind of curious, how exactly did you guys come upon this approach, this strategy? So like
Oh
the
yeah,
weights, yeah, yeah.
thank
So
you.
I'm curious
Like
how you
that.
came upon the strategy.
Yes. Yeah, thank you for the question. I would like to give a clarification that this is the credits from this work, this pure resampling work. Since I think our method is agnostic to resampling strategies, our job is to derive the TS and TY, like how features is distributed in the data set. So the resampling strategy on top of that, we can adapt to any one of them. And so we use state of our work.
Okay.
Like in this work, their work is very simple and elegant. Like we just trying to balance the ratio of sensitive groups and resolve like decorrelate the features, and that works well. So we adapt these methods.
Okay. Thank you. I'll check out the paper.
Yeah.
Thank you very much.
Thank you.
Okay, we don't have any additional questions, but I did have one question I wanted to ask for you as well, Mia. I know you work within, or you're a graduate researcher within the Visualization and Data Analytics Research Center. So could you tell us a little bit more about some of the other activities you guys do in the Visualization and Data Analytics Research Center at NYU?
Sure. Like we are a pretty like a large group. Like we include about 4 PIs and about 10 to 15 PhD students, and our work is very diverse. I know students have been working on medical imaging. And also remote sensing images. They are like pretty specific domain images. And for the algorithm part, I also know students working on a large like vision language models, and we even have like a reading groups on the current large models, and how do we apply them to our domain tasks. Yeah, so I guess me and like my advisor and has a specific interest in fairness and bias mitigation, or like a robustness for vision recognition. And we also have like application side of work that's use like remote sensing images on healthcare problems.
Okay.
Yeah, but that's like a very wide range of research going on in our center.
How often are the reading groups held?
Every twice a week, but since now is the like summer break is paused, I guess it will resume like in the fall.
Oh, okay. It's great that you guys have those. Are those open to the public as well, or interested parties outside of NYU?
I think that's open to public. Once we get like the new link, yeah, happy to share with you.
Okay, yeah, I'll pass it along. That would be interesting. So, okay. Let's see. We don't have any other questions in the chat. One more call for anyone else with any additional questions. Did you want to sneak one more in, Roman, before we end it?
Well,
No, thank you so much. I think, can you hear me?
Yes, we can hear you.
Okay. Yeah. I think the, in terms of safety research, we're basically at the frontier. I'm actually doing some work, in terms of, just creating synthetic data sets to build evaluation models. And, there's actually a lot of work to be done. So, so Mia would love to connect with you eventually to, to see what you're working on, and, I could share what I've seen from my end.
Okay. Yeah, I'm glad that would be very exciting. Yeah, thank you.
And likewise, Roman, we would love to at Cohere for AI to hear a little bit more about what you're doing as well. So if you want to follow up with me or Benedict with an email, we'll follow up with you, and maybe we can have you present at a future session.
Okay.
Okay.
Thank you so much.
That would really be nice. That would be nice, because it seems he does stuff with fairness and bias as well. So
yes,
that would be nice.
Yeah, and as it relates to industry, because from a professional level, I'm actually in cybersecurity. So just kind of bringing a lot of those ideas from that mature field. I think we're going to see a lot of practitioners from that side of the house, just instill some of their frameworks.
Mm-hmm.
Yeah.
Yeah. Yes.
Well, I have a small addition on my side. It's not technically a question, but Roman, this is a bit of an idea. I was like trying to cook it on my side. Not really sure how it goes. We all know that batch sizes affect models, and I was wondering, maybe we can try experimenting by passing balanced batches to the AI models and see how this goes on the bias mitigation side. What do you think, Roman?
Yeah, I'll actually defer to Mia as well. But from my perspective, bias measurements have always been from a statistical level. And eventually you're going to see a long tail of results. The more data you're feeding into it. What I'm seeing from my end is more about we have to figure out, we have to all agree on, if you're building a framework, what is fair and what is not fair, and that has been the biggest challenge. So building that taxonomy is what I see the biggest problem is at the moment. That's why I posed that question to me about the different cultures. How do we ground so that we can appease everybody?
Yes, I agree that to build a definition of a problem is the first challenge. Yeah, that's yes, and for the question, I also think it's good to explore the batch sizes influence to the training and how would this learning process manifest the bias from the data set. And I do not have very good feeling because I use like a stable batch size, but I think to experiment with different training schemes or schedules could be a good experiment. Yeah.
Mia, I was talking about passing balanced batches to the AI model instead. Meaning like maybe we can pass in
Sure.
4 smiling images and 4 non-smiling images at the same time to the AI model.
Sure. Yeah, that essentially I think is also a pre-processing method to revise the data set into a balanced one. But if like one group of samples is very limited, to ensure the balance, we will like lose information from other samples, and it should be considered whether that will affect the general accuracy of the classifier. So I guess that's why people are more prone to using reweighting, like to still include the bias samples, but to reduce their weights and to increase the frequency of the unbiased samples, and together with augmentation strategies, so that you can create various unbiased samples.
Yeah, and I'll also add too, because I think your question really is in the area of the fine tuning, and there's always a trade-off, because when you have smaller batch sizes versus the larger batch sizes, you don't want to overfit to a particular feature or attribute. So like Mia said, it's really about the strategy and how you want to trade off within your pre-processing of data.
Yes, makes sense.
Okay, well, I think those are our questions for today, Mia. This has actually been great because I like the fact that we had a chance to add some additional questions and some additional feedback to the presentation. So
Yeah.
thank you again for your time today. And on your last slide, I believe you had an email for folks to contact you with any additional questions, right? Okay. When we put out the video in a couple of days, we'll make sure that your email's available if anyone needs to contact you.
Yeah, sounds good. Thank
Okay.
you. Thank you,
All right.
everyone.
Well, thank you again, and thanks everyone for attending.
Yeah, thanks.
Okay, bye.